All right, so before we look at the problems that go with this directions, let's kind of review something from a previous course because we're gonna need that idea with this. So in a previous course, you had something like this. Number one, 3/8 is equivalent to what fraction with a denominator 24? Okay, that's the idea. The process you use here will be very similar to the process you use with polynomials, with variables, with numerators and denominators involving variables. So when you did this one, how did you write an equivalent fraction that had 8 as a denominator to something that had 24? What'd you do? You multiply the denominator by what? 8 times what's 24? 3. All right, so you said times 3. What I did to the denominator, I did to the numerator. So 3/8 is equivalent to what fraction with the denominator 24? 9. And if you reduce 9 divided by 24, you get 3/8 back. All right, number 2. -4 divided by 9 is equivalent to what fraction with 18 as the denominator? So what do you think that numerator is going to be? 8? Not quite. -8. Because you said 9 times what's 18? 2. And so what I do to the denominator, I do to the numerator. So -4 times 2 is -8. Okay? All right, now, let's look at those with variables. So number 1, 5x divided by 6y, that's a 6, y. So this rational expression, you want to rewrite this so that you have this denominator, 18x squared y to the 4th. 18x squared y to the 4th. Okay? So, remember, you just want to look at the denominator first. This is what I have. This is what I want to end up with. So 6 times what is 18? 3. So I know I got to multiply this denominator by 3. Okay? Now let's look at this y. See, I have a y here, but I want to end up with y to what power? 4th. So y times what will give me y to the 4th? Y to the 3rd. Y to the 3rd. Because remember, you multiply like bases, you do what with those exponents? You add them. So I got to multiply. So far I know this. I know that I got to multiply this denominator by a 3y to the 3rd, right? But will this product right here give me all of this? No, what's missing? X squared. So I know I got to multiply it also by what? By what? X squared. So just like we did this one, 3 times what is 24? I'm sorry, 8 times what's 24? 3. And what I did to the denominator, I have to do to the numerator to keep it equivalent. Okay? So if I'm going to multiply the denominator by 3y cubed x squared, then I've got to also do it to the numerator. All right? Now, let's look at the numerator right here. Notice what you see here is this. You see 3x squared y cubed times, that's multiplication right here, times 5x, that's times right here, times 5x. What is that? 15. Let's put an alphabetical order. 15x what? Yeah, because x squared times x is x cubed, and then y to the 3rd. You agree? All right. Now you can check this. Watch what happens when you check it, if you want to check it. So you see this right here? I have this. So let's kind of remind ourselves about certain things. All right. So I want to see if this is going to give me my original back. Well, let's look at 15 and 8. What do 15 and 8 have in common? What's the GCF of 15 and 8? 3. So 3 goes into 15 5 times. 3 goes into 18 6 times. So you see you got a 5 divided by 6. Is that what you have here? Yeah. Now let's look at the variable x's. So in the numerator, I have how many factors? I have 3 of them. In the denominator, I have how many? 2. So when I reduce, remember we reduced in a previous lesson, I just end up with x divided by what? 1. And so notice that I have x in the numerator, and remember x divided by 1 is the same thing as what? X. So that x is located in the numerator. Okay, let's look at the y's. I have how many factors of y in the numerator? 3. I have how many factors of y in the denominator? 4. And if I reduce, I get 1 times 1 times 1, which is 1, divided by y. Oh, I'm sorry, 1 times 1 times 1 times y, which is y. Where's that y located? In the denominator. All right, so do y'all agree that this right here is this? Because look, this is what I have. I want to show you. You get 5/16, right? And y'all agree that this right here is x over 1? And do y'all agree that this right here is 1 over y? Okay. What's 5 times x times 1? What's 6 times 1 times y? 6y. And that's what this was. Okay? All right, so that's number 1. Number 2. All right, look at number 2. We have this. We have 22y divided by 4y minus 3. So there's your rational expression. And you want to write an equivalent rational expression that has this denominator, 12y minus 9. All right, now, remember when you dealt with rational expressions from that first section, 14.1, what was it that you did most of the time at the beginning when you dealt with those rational expressions? You factored. All right, you factored. So if you look at 4y minus 3, can I factor 4y minus 3? No, see, that's a binomial, and so the GCF is what? 1. Can I factor 12y minus 9? Yes. How do I factor that? 3 times 4y minus 3, right? Okay? Now, look at what you have. Look at what you want. What factor am I missing? What do I need to multiply this factor by to get this denominator? 3. I'm going to say times 3, but what I do to the denominator, I do to the numerator. So what is the numerator right here? 66y. Okay, 66y. Number 3, you have 5 divided by x squared minus 49 equal, and then you want to write an equivalent rational expression to this that has this denominator, x minus 7, x plus 7 times x plus 8. Okay, so x minus 7 times x plus 7 times x plus 8. What's the first thing you need to do before you begin to write equivalent rational expressions? Factor. So look at that first denominator. Can I factor that denominator? Yes. It's the difference of 2 squares. So how do you factor x squared minus 49?
X plus 7 times x minus 7.
Okay. Can I factor that second denominator? Can I do anything with it?
No.
Why not? Because it's already factored. Everything's listed as factors. How many factors do you see? 3. All right, now look at what you have and look what you want. So what factor am I missing?
X plus 8.
X plus 8. All right, so I'm going to say times x plus 8 in parentheses, just like this, But what I do to the denominator, I have to do to the numerator. So times x plus 8 in parentheses. So what's the numerator?
5.
5 times x plus 8. All right, now you can leave your answer like that.
5x plus 4.
What was the other one?
5x plus 4.
Yeah. All right, so what he did was he distributed the numerator. So now remember, always leave the denominator factored. Don't. Now, if you multiply it, it's no big deal, but leave it factored. And I would leave the numerator factored as well. I would leave it as 5 times x plus 8. But it is okay. It is okay if you said this. Multiply this out, the numerator, distributive property, you get 5x plus 40. And then divided by, and leave these factored. So x minus 7 times x plus 7 times x plus 8. Okay? So you wrote equivalent fractions. Now let me just say this though, and you're going to see this in my math lab. And my math lab is going to say this. It'll say,
Excuse me. Can we cancel out x plus 8?
no, okay, that's a good question. He's asking this, can you reduce these? The problem is you get this back, right? But that's not what you wanted. So don't confuse that with what you did in section 14.1. Section 14.1 said simplify. That was the direction. So in 14.1, you would have been given this, and you would have been told to simplify. Then you would have reduced the x plus 8, and you would end up with 5 divided by x squared minus 49. But the directions here don't say simplify. The direction says write equivalent fractions. All right, so yeah, so you have to know what the direction says. Yeah, but that's and some students do that without thinking about, well, what am I doing here? So just make sure you understand what the directions are and what the context of this is. Now on my math lab, it's going to say this. It's going to say write the answer. Write the answer as fully expanded or factored form. So you're going to see that in my math lab. You're going to see those instructions or directions. So let me tell you what that means. So when it says write the answer as fully expanded or factored, so you can write it one of two different ways. So you can write the answer in factored form. And I'm going to ask you this. I'm going to circle these two right here. I'm going to ask you, which of those do you think is in factored form? The numerator. I mean, the first one, right? Because the numerator is factored. So that's what they mean by factored form right here. Which one of those would be in expanded form? The second one. So that's where you use a distributive property in the numerator. So you wrote it as 5x plus 40. So you agree that 5x plus 40 is no longer factored, right? Okay, so that's called expanded. All right, so this is expanded form. So just be aware that that they do have those instructions, but it doesn't matter which one you write it as. Okay, number 4. Okay, in 4, you have this. You have 7 divided by 3x plus 12. So there's your rational expression. You want to rewrite this, though, with this denominator. 3y times x plus 4. So you want to find out what must that numerator be? What must that numerator be for this rational expression to be the same as this one with that denominator? All right, so what do you think you would need to do first?
Factor the first fraction.
Factor the first denominator. So 3x plus 12, how do you factor that? Factor out of 3, and what are you left with? 3 times x plus 4? All right, look at what you have, and look at what you want the denominator to be. So what must I multiply this denominator by to get this denominator? Y. So I'm going to say times y, just like this. Now that one's easy in terms of the numerator. The numerator is just what? 7y. That's the numerator. All right. And you know you can always check your work. Okay, so watch. This is what I started out with, right? Y'all agree? And this is what I'm saying this is equal to. So this is equal to 7y divided by 3y times x plus 4. Y'all agree? So if I reduce this, do I get this back? Is a question. So what can I reduce here? The y's. And that's the only thing I can reduce. What's the numerator? 7. What's the denominator in expanded form? 3x plus 12. Okay? All right. So this is your answer. Number 5. In 5, suppose we have 3x divided by x cubed plus 3x squared minus 10x. So 3x divided by x cubed plus 3x squared minus 10x. And I want to write an equivalent rational expression with this as the denominator, though. So I want my denominator to be this. X times x plus 5 times x plus 6 times x minus 2. All right, so what's the first step you're going to do? Factor. Okay, good. So how do you factor that first denominator? So I'm going to go off to the side and do that, because y'all agree that that first denominator is not factored, right? But what do you notice about that second denominator? It's already factored. You can even see the factors. X, what's the other factor? X plus 5. The other factor is x plus 6. And the other factor is x minus 2. So I'm going to go off to the side. I'm going to rewrite this one. So I get x cubed plus 3x squared minus 10x. So on the last test, how did you factor this trinomial right here? Okay, what's the GCF? X. So you said x times x squared plus 3x minus 10. What else did you do, though? You factored that trinomial. So that became x times, let's see, there'll be x, 5 and 2. 5 is going to be positive, and the 2 is going to be negative. So that is this. So that'll be x times x plus 5 times x minus 2. Okay? Now you can tell me what I need to multiply this denominator by to get what I want. X plus 6, right? So you say times x plus 6, just like this, times x plus 6. Notice I put x plus 6 in parentheses. Now do y'all see that this denominator is now this? So the numerator, put in factored form first. So what would this look like in factored form for the numerator? 3x times x plus 6. Okay? So that's factored form. Or if you want to expand it, although I would just leave it like this, you could say 3x squared plus 18x divided by, and then those factors, x times x plus 5 times x plus 6 times x minus 2. All right? So either one of those is fine, although I would have just left it like this. All right, again, if you reduce, if you check yourself, if you reduce this, you'll get the original back. Number 6. you have this rational expression, negative 2y minus 7, divided by 20x squared plus 15. And you want to rewrite this using this denominator, 60x squared plus 45. Okay? All right, what's the first thing you're going to do? Factor the denominator. So how can I factor that first denominator? GCF of 5. So it'll be 5 times 4x squared plus 3. All right. What about that second denominator? GCF of 15. Good. So it'll be 15 times what? 4x squared plus 3, right? So look at what you have and what I want. So I have the factor 4x squared plus 3, but I need a 15 also. And all I have is a 5. So 5 times what's going to be this 15? 3. So you can say times 3 times 3. Okay, notice I said times 3 just like this. But what's going to be the numerator? How are you going to write the numerator, though? Tell me what to write. And write it in factored form first. 3 in parentheses times what? Negative 2y minus 7. Okay? So that's factored form. All right? Now, there is a problem on My Math Lab where it's going to say this. It's going to say, do not leave in factored form. Do not leave in factored form. So if it says do not leave in factored form, then it means write it in what? In expanded form. So that would not be the answer right here. What would have to be the answer then? Yeah, negative 6y minus 21 divided by, and it doesn't matter which of these you use. I'm going to use the factored form down there. So when they talk about writing factored form or expanded form, they talk about the numerator. That's what they're referring to. Okay. All right. So any questions on this? All right. So that takes care of 14.3. So that's that section.